Hello and welcome, my name is Nias, and today we're talking about image captioning in personal photo management, a comparative study of different techniques. In the last half year, I looked into image captions and what it means for personal photo management and looked at all the different techniques I could find. But before we can start with that, we have to first talk about image captions. Image captions are not like a standardized thing. They're very different from platform to platform or what you want to achieve with it. For example, I have here 4 examples: Instagram, Twitter, Google, Wikipedia, and CNN. And the first image, Instagram, obviously wants to more communicate like a vibe. And they have like a different mechanism with hashtags, so everything is searchable via tags. And Twitter is more like reacting to other people, or well, now it's called X anyway. And they do image captions for like accessibility purposes. Wikipedia is like the classic example. It's very factual. Okay, what's on the image? I'm going to just describe that. And like when you look at like news sites, they usually are also factual, but they also have this thing of attribution within it. So as you can see, a lot of different ways to create image captions. And so now we have to explain the second part. What is personal photo management? Personal photo management is software that helps you sort your images. Usually you collect them over a lifetime with different devices and you want to sort them. And these days we have too many images, so we need some software for that. Common sort criteria are when, where, who, and what. This all came like from back in the day where you had like photo albums and you would usually sort them by like year and then cluster them by events or by a person. For example, like a birthday of XY. And these days we usually do it like in an automated fashion, like with machine learning. So you have like face recognition and then you know, okay, we have this person in the image, and with metadata. So for example, we can sort by, we can extract all the dates and then we can sort by month, for example, and locations are also something that's within the metadata. And image captions are not, are rarely looked at, and that's why it's very interesting to look into it. So that's why I did it. And so why is it interesting for me? I'm the maintainer of LibrePhotos, an open source self-hosted system, which is maintained by me since 2020. I forked it from Own Photos, which was abandoned, and it's quite popular. Like we got featured on Ars Technica, and it has like 2.4 million Docker downloads. So, and I also have implemented like a lot of common functionality already, which means you can already like upload images and they're all sorted and you see who's in it and stuff like that. Now I have to understand what users actually want. So I did a little survey. I asked 20 LibrePhoto users with like a Google Forms survey, and I also added the option to upload your server stats so that I understand, okay, what kind of systems are the users using. And I got a lot of requirements back I have to look at. So the user needs are that it should be self-hosted, private, obviously. So it should still be like a self-contained system. It's not possible to use an API. People look very skeptically at that when it comes to their own photos. It should be as accurate as possible, obviously. Some people don't really care for that use case, so it should be optional. Hardware accelerated, it's also like a big point. So you should be able to use like a GPU or like an NPU. And it should be customizable, so more factual or like more creative. And like a very important thing is a usage of previous attained knowledge, like persons or locations. People want to have very descriptive caption with things they already know. So not like a description like a man standing in front of a tree, but something like Nias is standing in front of a tree. And the limitations are that we have less than 8 GB of RAM. The reason for that is that most users who have like a self-hosted system use their old system. So it's usually 5 years or older, which creates quite a lot of limitations. For example, we also have the limitation that we can't use fancy instruction sets like SSE4, AVX or AVX2, because I have some users who have like still running like an Intel Core Duo. So any of these optimizations are not on the cards, and I have to make sure that that doesn't crash. Yeah, you can see in the graphs, obviously like a lot of old systems and dev systems are a magnitude faster and have more RAM, which is obvious, I think. Okay, then I had to establish like a baseline. We already had like an image-to-text model called im2text. It was based on a PyTorch tutorial. It was a CNN LSTM encoder-decoder architecture. And I didn't know how well it worked because it was never benchmarked. So I looked into the common benchmarks and established a baseline, which means I used the Coco dataset and then ran all the image captioning benchmarks like BLEU, Meteor, Rouge, Cider, and Spice. And yeah, then I got these scores back. Then I looked into optimizations because we obviously don't have like a lot of resources, and looked, okay, how can I make it run faster? The first thing I noticed, okay, I/O is very important. You should keep the model in RAM, otherwise it will take a while. GPU acceleration obviously makes it even faster. Every processing you can do, only do it once and try to not do it again. And then I looked into converting to an NX that worked for the im2text model, but quantization didn't work. I ran into like a lot of issues with that, like unsolved GitHub issues basically. So for the rest of my master thesis, I didn't look into it because it seemed like a topic for itself. And then I looked into like a more, a newer architecture. I just looked into like a transformer-based image-to-text model where Blip obviously made a lot of waves. And then I benchmarked it too. Got the scores back. It was not the fine-tuned model, but the ground model. And then I compared it to the fine-tuned model. It seems like you can reach way higher scores than with the base model. But for the whole implementation, I only stuck with the base model. Okay, yeah, so then I had the idea, okay, how can I add a previous attained knowledge to my captions? A large language model would be the solution, because large language models are very good at solving semantic text tasks. And I also looked into, okay, maybe it could even translate captions, which is also like a thing. We have like some multi-language support, obviously, if you want to have like a self-hosted system for a lot of users. And yeah, I don't think I have to explain large language models. They're obviously language models which are very large. So we throw a lot of training data into it and a lot of training time. And then we have models who can do things they're not explicitly trained for, which now generate a lot of hype. And I wanted to look into, okay, can I solve it with that? The criteria obviously still should be self-hostable, so less than 8 GB of RAM, which is difficult. So I have to use a quantized model because like every 8B model takes too much RAM, usually. It needs to have a fitting license. We are MIT licensed, so no Llama license, only Apache license or like MIT license is possible. And it should perform well enough for the tasks. I was lucky. In November, Mistral 7B was released. And I was like, that's perfect. It broke every benchmark back then. And I was like, okay, I will just use this in a base model with a base model and in a quantized form by the bloke. And then it should run with an 8 GB of RAM. Okay, then I had to test, obviously. Does it work? And then I looked into, then I created a little study in Lime survey. I took 20 images from my personal photo collection and created 3 captions for them with like the old system, Blip and Blip plus LLM. And users should rate the captions from 1 to 5. All the images and the captions were shown in randomized order. And you only saw like one caption and you didn't know which one, which is obviously important. Then I got 62 responses, and every person rated all 20 images. So I got like a lot of data. And then I also wanted to use like some quantitative measurement. So I looked into ClipScore. ClipScore is like a reference-free method for evaluating captions. The paper said that it performs similarly to the other captioning models, but they need like images and captions by itself, like as a base measurement, and then you compare it to the generated captions. But I obviously don't have that for my images, and it didn't sound that scientific to just create the captions by myself and then run the scores, because it's probably very sensitive to how you write it. Yeah, but in ClipScore you don't need it. Clip is for image retrieval. This means you have like a text which gets converted to an embedding space. You have images that get converted to an embedding space, and then you can run like similarities calculations based on that. And you can basically compare, okay, how similar is this text to this image? And you can obviously also use this for evaluating how well the caption works. Yeah, so then I looked into it. ClipScore can identify bad hallucinations, which is the first thing that is very cool. So you can basically run a multi-shot procedure and then rate all the different captions that get created, and can mitigate basically hallucinations, which is very nice. In general, it increased, but I don't know what this means, because it's not clear how well the ClipScore and like user preference aligns. It could be very different. And usually all these captioning methods only look at how accurate a caption is, but not how much people like it, which is the more important thing. Yeah, so then I got back a lot of data basically. And now we have like here this plot chart. And as you can see, Blip and the LLM did not perform better than just Blip, which is quite sad. This was because of a couple of different scenarios. First of all, I looked into every different possibility. So I had like a lot of different images that didn't have had any additional context. So, and then the LLM could, in the best case, only improve like spelling and like capitalization basically. But in the worst case, it hallucinated, and then people really didn't like it. The same thing happened with names. It didn't matter if it was hallucinated or not. People do not like names, at least not in this study, in this context. They found it creepy, which I found very interesting, which is something you have to look at. Maybe it behaves differently, like in a context of a photo management system, where people see, okay, directly above the caption, okay, the system already knows that person in here. But without that, they really don't like it, which is interesting. And but users liked the addition of places, which doesn't make too much sense to me, because this is also like identifiable information. But they liked it in their captions, and it performed better than the regular Blip model. Okay, so what can I look into in the future? Obviously, trying out state-of-the-art models like ChatGPT or multimodal models. If you don't actually look into the self-hosted part of my master thesis, then you can use these bigger models, which obviously have like a lot of cool features and perform better. And then you can really push it to the limits, which obviously is not possible with a small quantized model. It would be interesting to look into that. The second thing is there is no benchmark or data set for like user preferences with captions. So everything I tried, and also like with like previous attained knowledge, is not like a thing yet. So it's not exactly clear how you would approach that. And I think this could be a paper in itself, basically. Then you could solve maybe with the same architecture, just adding like a new OCR system to it and solve something like text caps, where you caption images, but there's also text in it. I saw that some multimodal models can also do that, but it could be that the less smart version also works better because like you have like an expert system, obviously. Then you could look into multi-language support, right? So you have like now a large language model, and then you try out how well it does at like translating to different languages and what are the limitations, because that's also unknown yet. And then, and this is something I didn't do, but is like an easy win basically, you could look into all the different fine tunes. There are like a million of them, and they all behave slightly different. Yeah, and then you could also potentially create a new one, and maybe a couple of these fine tunes are already very good at like captioning images and adding the previous context into it. Yes, and this was basically my whole master thesis. And now I show a little demo of all the things I added while I was writing my master thesis.